Hi, this is Hilal. In this video on Mathematical Economics series, we will learn about the matrix multiplication. That is how to multiply two matrices. Now, the matrix multiplication requires, the first condition is that matrices must be conformable. Conformable means that the number of columns in the first matrix, if we are given the two matrices, this A matrix and B matrix, then the number of columns in the first matrix, which is called the lead matrix also, must be equal to the number of rows in the second matrix, which is called the lag matrix. Now here we can see the number of columns are 1, 2 and 3, and here the number of rows are 1, 2 and 3. Since the number of columns in the first matrix are equal to the number of rows in the second matrix, then these two matrices are conformable. Then we can multiply these two matrices. Now, a general formula for seeing whether the matrices are conformable or not, if we are given the matrices, first matrix is of dimension m times n, and the second matrix is of dimension n times p. Now what will we do? We will encircle these two elements or numbers here. Since these two are equal here, this means the two matrices are conformable, and the resulting matrices is of dimension, that is m cross p. In the earlier videos I have explained what is the dimension of a matrices. Dimension of matrices is the number of rows multiplied by the number of columns. Now if we apply this on this formula on the given example, here the dimension of this matrices is number of rows are here 2 and number of columns are 1, 2 and 3. Similarly here the number of rows are 1, 2 and 3, and the number of columns are 1 and 2. Now if we apply this formula on this, that is the dimension of this matrix is 2 by 3 and the dimension of this matrix is 3 by 2. Therefore we can see here 2 into 3, and I will write the dimension of this like 3 into 2. Since these two numbers are equal, then these two matrices are conformable, and the resulting matrix after multiplication will be of dimension 2 by 2. So this is an example of the two matrices which are conformable. Now if I have another example, let us say I have an example. I have a matrix A is equal to, that is, let us say it is 2, 3, 4, 1, 5, 6, and I have second matrices, that is B is equal to 1, 4, 2, 6, 4, 0, let us say. Now if I apply the same formula, that is m cross n and n cross p, now these two numbers must be equal. Now here the dimension is here 1, 2 and 3, number of rows are 3, and the number of columns are 2. Here the dimension is also same, 3 rows and 1 and 2 columns. Now to see whether these two matrices are conformable or not, we will apply this formula or visualization method. Now here this is 3 into 2, here also 3 into 2. Now we can see here these two numbers are not equal. Therefore, we can say that we can't multiply these two matrices. So these matrices are non-conformable here. So the first condition to multiply any two matrices is to see whether the two matrices are conformable or not. Conformable means the number of columns in the first matrices must be equal to the number of rows in the second matrix. Here we can see the number of columns are here 2 in the first matrix, but the number of rows here are 1, 2 and 3. So these two are not conformable. Now, after being sure that the two matrices are conformable, we can go for the matrix multiplication. In this case, these two matrices are conformable because the number of columns in the first matrices are equal to the number of rows in the second matrix. Here the number of columns are 3 and then here the number of rows are also 3. Now, after that, each row vector in the first matrix, that is the lead matrix, is then multiplied by each column vector of the lag matrix. Now, each row vector here is multiplied with this column vector. That is, row vector of the first matrix is multiplied with the column vector of the second matrix. Now this is to be remembered that use only rows from the first matrix and columns from the second matrix. We have to use rows from the first matrix and columns from the second matrix, and not the columns from the second matrix and rows from the first matrix. We have to use only rows from this matrix and columns from this matrix to multiply the matrices. Now, row column products, this row column products are also called inner products or dot products. Now these row column vectors are then used as elements in the formation of product matrix. Now we will see. Here I have denoted these columns by C1, C2 and C3 and rows by R1 and R2. Similarly, I have done the same here. Now, making sure that we use only rows from the first matrix and column from the second matrix. Then the matrix multiplication is done by first we take row of the first matrix and we multiply this by the column of the lag matrix to find the element of first element. Now we have to multiply the first row, that is R1 of the lead matrix with the first column of the lag matrix, that is R1 C1, that is this R1 row and C1 column to get the first element. After that, we take the first row of the lead matrix and we multiply it by the second column of the lag matrix to get the second element, this element. Similarly, since there are no more columns left in this lag matrix to be multiplied by the first row of the lead matrix, now we will move to the second row. That is, we will multiply the second row of the lead matrix with the first column of the lag matrix, that is R2 and C1, R2 times C1 to get this element, third element. Similarly, we take the second row of the lead element and we multiply it by the second column of the lag element to get this, to get the fourth element of the matrix. Now we will see how it is done. It is here. Let's I place this here. This will become a into b, that is a times b is equal to, now I have to multiply the row 1 of the first matrix. This is this row with this column, so this will become 1 into 2, that is 1 into 2 plus 3 into 1, that is 3 into 1 plus 2 into 3 plus 2 into 3. Now this is the first element. Similarly I will take the row 1 and column 2, that is row 1 and column 2. So row 1 will be multiplied with this column 2. This is 1 into 3, so this is 1 into 3. Now 3 into 4, this is 3 into 4, and 2 into 0 plus 2 into 0. Similarly, we have to take row 2, that is this row and the first column. So this will become 4 into 2, that is 4 into 2 plus 1 into 1, 1 into 1 plus 5 into 3 plus 5 into 3. So this is the third element. Then R2 C2. Now row 2 and C2. This is 4 into 3, this and this, plus 1 into 4, 1 into 4 plus 5 into 0 plus 5 into 0. So this will become, now this is 2 ones are 2 plus 3 ones are 3, so this is 2 plus 3 plus 6, that is 2 plus 3 is 5, 5 plus 6 is 11, so this is 11. Here 3 ones are 3, 3 fours are 12, so this is 3 plus 12 is 15, and 15 plus 2 into 0, this is 0, so this is only 15 here. Similarly, this is 4 twos are 8 plus 1 ones are 1 plus 5 threes are 15, so this is 8 plus 1 plus 15, so this will become 8 and 1 is 9, and 9 and 15 are 24, so I will write here 24. Similarly, this is 12 and this is 1 fours are 4, so 12 plus 4 is 16 plus 5 into 0, this is 0, so here it is 16. So AB is equal to 11, 15, 24 and 16. So this is the matrix multiplication, and only one thing is to be remembered, that is we have to use the rows of the first matrix and columns from the second matrix. Now we have seen if these two matrices were, these were the conformable matrix, because the dimension of this matrices was 1, 2, number of rows were 2 and columns were 3. Similarly, here the number of rows were 1, 2 and 3, and the number of columns were 1 and 2. Now, since these were, this is to be remembered, for conformability we take this dimension, that is 2 into 3, and the dimension of the second, that is 3 into 2. Since these two are equal, then we can say that these two matrices are conformable. I am repeating, the important pointers. Now the resulting matrix was this. These two left out numbers, that is 2 cross 2, which we got here. This is 2 cross 2. So this was all about the matrix multiplication. For more videos on mathematical economics, please subscribe Econ Maths on YouTube. Thanks.